Hello guys, this is Camille Gamarcha, the in charge of discussion in this group.
Hello guys, I am Janelle Rosette G. Pineda, the in charge of the procedure in this group.
Hello guys, this is James Kurt Ayon, in charge of the table on this video.
I'm Will Rose Castellano, in charge for the analysis of this group.
Hi, I'm Dr. Paul Mayari, the in charge of the conclusion in our group.
Hi, I am Justin J. Peron and I'm in charge of the editing of this group.
In our PhET simulator diagram, we have here the ammeter, which we use to measure the current. We also have the voltmeter, which we use to measure the voltage. Together with these two are the resistor, the switch, the battery, and also the wires.
In our laboratory experiment 4, we are tasked to verify the Ohm's law principle using the PhET simulator, circuit construction DC. First step is we put the battery and attach some wires to it. After attaching wires, we then attach the ammeter for us to easily measure the current it produces. We then added more wires and attached the resistor. In order to get the voltage produced by the resistor, we attach a voltmeter to it. After attaching the resistor, we added more wires and a switch to complete our circuit. After closing the switch, we started gathering data by simply setting the battery's voltage to our choice and adjusting the resistor's value in an increasing order all throughout the 5 trials. After gathering all the data needed, we then proceeded in doing the computations of the theoretical voltage and the theoretical current. For the theoretical voltage, we just simply multiplied the experimental current and the resistance. And for the theoretical current, we just simply divide the experimental voltage to its resistance. We used the same formula in all 5 trials.
Ohm's law states that the strength of a direct current is directly proportional to the potential difference and inversely proportional to the resistance of the circuit. In formula, we have V equals IR, where V is voltage, I is current, and R is resistance. Let us take for example trials 1, 2, 3, 4, and 5. We have set the resistance in an increasing manner. In trial number 1, the resistance value is 800 ohms. To get the experimental voltage and the experimental current, we use the simulator where we set the experimental voltage at 30 volts. We then have the experimental current, which is equal to 0.04 amperes. To get the theoretical voltage and the theoretical current, we use the formula V equals IR. For a theoretical voltage, we have I, or current, which is a value of 0.04 amperes, multiplied by resistance, which is the value of 800 ohms, which gave us the value of 32 volts for voltage. For the theoretical current, we used the formula I equals V over R, where V is equal to 30 volts and R, our resistance, is equal to 800 ohms. So we attain a value of 0.375. The same goes for trials number 2, 3, 4, and 5. In trial number 2, our theoretical voltage is 24 volts, while our theoretical current is 0.025 amperes. In trial number 3, our theoretical voltage is equal to 29.45 volts, while our theoretical current is equal to 0.1935 amperes. In trial number 4, our theoretical voltage is equal to 28.8 volts, while our theoretical current is equal to 9.375 times 10 raised to the negative 3 amperes. And in trial number 5, our theoretical voltage is equal to 31.8 volts, while our theoretical current is equal to 5.660 times 10 raised to the negative 3. Ohm's law is a formula used to calculate the relationship between voltage, current, and resistance in an electrical circuit. This law was first experimentally verified by a German physicist, Georg Simon Ohm. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. Ohm's law equation is V equals IR, where V is the voltage across the conductor, I is the current flowing through the conductor, and R is the resistance provided by the conductor to the flow of current. Voltage is in volts, current in ampere, and resistance in ohms. We can make use of the Ohm's law magic triangle to remember the different equations for Ohm's law used to solve for different variables. If the value of the voltage is asked and the values of the current and resistance are given, then to calculate the voltage, simply cover V at the top. So, we are left with I and R, or I times R. So the equation for voltage is current multiplied by resistance.
Ohm's law states the relationship between electric current and potential difference. The current that flows through most conductors is directly proportional to voltage applied to it. To verify Ohm's law, we need to measure voltage across a test resistance and the current passing through it. The voltage can be measured by connecting high resistance. Because the resistors are connected in series, the same current flows through each resistor as well as the total resistance. The total voltage across the resistors are equal to the sum of the potential difference across, as shown in the above table.
According to the result, the higher the voltage, the higher the current, implying the voltage is directly proportional to the current, as stated by Ohm's law. It means that as long as there is no resistance or the resistance remains constant, the current will still rise as the voltage is increased.